As we get into more difficult and complex logic, we need more powerful error handling scenarios. And so let's talk about what those might be. You could have a lot of different bad things that could happen in your program, but I respond the same way. So, for instance, I could be doing some work where maybe the file is not there, or when I try and write to the file, it's read only, or as I'm writing the file, the hard drive stopped working. But generally speaking, it doesn't matter what went wrong with the file. We tell the user the same thing. Hey, whatever file you want us to work with, it didn't work. So try again later or pick a different file. That's all we can do for you at this point. That's pretty standard scenario and not too difficult to deal with. We just have to plan it out accordingly using some of the advanced features. The alternative is maybe there's a lot of bad things that happen. The internet could go down. Like maybe we're chatting with somebody else and the internet's still there, but their app's not responding. Or maybe our hard drive really went wonky all of a sudden and we can't do it anymore. So based off of what went wrong, we don't want to just say, hey, stop your machine, start over again. Yeah, that's not the right answer. So if the internet is down, maybe we try again every 10 seconds until a minute goes by, and then we pop up an error message saying, looks like your internet connection's down. Then we keep trying, even if it's down, until we get reconnected. If the other app we're talking to stops responding, then maybe what we do is say, hey, the call was lost. Then give them the option to call again. Versus if the application's unstable, maybe we say, hey, we got to shut down. This is not working right because we don't want to screw anything up. And so we're just going to stop working. So those are three totally different responses to three totally different things that could all happen based off of maybe the same call that we have going on. So we need to handle both of these complicated situations. So the one is a little bit easier because by its very nature, this inheritance hierarchy, when I say something like catch exception, I don't just catch things that are exception. I catch exceptions in anything that's a subclass of an exception. So all runtime exceptions, I/O exceptions, SQL exceptions, and then all types of runtime exceptions, arithmetic exceptions, index out of bounds exceptions. So the case where I want to catch whether the file was not found, is unreadable, all that sort of stuff, I can just say handle exception. I'm sorry, handle IO exception, pardon me. Just the things that are wrong with reading and writing files, I just handle those things. And it handles with all those details. Just a single catch block will work inside of that for me. But remember, it just handles that family. So when I set up that family, if something goes outside of that family, such as like an out of memory error, I don't handle that. That's both a positive and a negative, depending on how you look at it. It means I can very customize, surgically handle certain things, but it also means that I might have to have multiple handlers to deal with multiple things that are going on, especially if they're not related closely. So the other thing I want to throw in there is when you handle an exception, it means it's handled. So if we have code like this, we do the stuff and we catch all throwable errors. Anything that could possibly go wrong here, the word throwable inside of here. Well, when you say that, you're saying that I've handled this fire. It's taken care of. And the program assumes it's been taken care of. If it just told you that you're out of memory for your Java program and you try to do something that allocates more memory, it's going to blow up again. And maybe you handle that and it blows up again. And then your program's really, really hosed. It's going to keep blowing up, blowing up, blowing up, blowing up in this never-ending cycle. And it could cause some really big user abrasion because they have to go and kill your program by hand. So you want to be careful where you handle exceptions and how you handle exceptions. You don't want to pick too high, if you will. Only handle the things you know how to handle. Because the next step is assuming the program's going to work well after you've handled that problem, after it's gone away. So telling the user something wrong might not be an option. You might end up prompting the user, hey, something went wrong. Okay, something went wrong. Okay, something went wrong. Okay, you told me that already. So the way we can solve that sometimes is through multiple handlers. This is the rudimentary way of handling it. So in this code, you can see I have a method and I have a try catch with another try catch inside of it. So I'm doing some stuff, and if a SQL exception happens, I do that. And if it's not a SQL exception, the I/O happens outside of that. Because the rule of this is, there's nothing really fancy here. We're just using the basic stuff. But any exception that's not handled within the first try-catch block, anything that's not a SQL exception, continues to live on. it skips this and goes on to the outside. And then say, oh, look, there's another one, IO exception. And if it's an IO exception, it'll handle that. And that's just the basic rules of doing this. But I can nest them. That's what you call when you put one thing inside of another, nesting it. I can nest these inside of each other. SQL exceptions are caught in the first handler, and so on and so forth. Now, if none of the handlers inside of those blocks, if the try catches don't cover it, I get to the end of the method, then all bets are off. That method's toast. It goes back to the calling method, and all bets are off for whatever block I was called in up there. So the handlers get the first shot at correcting the errors, but anything that's not stated inside of there automatically gets propagated. So if a arithmetic exception occurs, if a index out of bounds exception occurs, if a stack overflow error occurs, they immediately skip all these handlers and jump up. Then they go to the calling method, which then in turn goes to a calling method, which then in turn goes to a calling method, all the way up to the main method. And if you get all the way up to the main method and nothing's handled it, then Java handles it. Now, Java handles it very intelligently for the most part, because Java programs rarely give you the old blue screen of death if you're talking about Windows or whatever the equivalent is on Macs and other operating systems. Java will tend to cut it off, terminate your program, and spit out something to the user about an error code or something like that, maybe, or it just dies, just goes away. The idea of error handlers is to stop that from happening. I can walk up the chain, but I can put stuff at a very high level to say, hey, if anything bad happens, just say thanks to the user and go away. Just let that happen. And that's where our error handling strategy comes in. Now, we're not dealing with all that right now, but just to understand the mechanics of this advanced error handling, it walks up the chain. Now, Java gives you a little bit of helper inside of that, allowing you to not have to have this propagation all the way up for each different type of things and have to have nested handlers and whatnot. Java will actually allow you to have multiple catch statements on a try. So if I know some bit of code could throw an IO exception, it could throw a SQL exception, or just some other type of exception out there, 3 parts of the exception hierarchy, I can have different responses inside the single try statement. So I could say, if an IO exception happens, then tell the user, sorry, the file couldn't be read. Pick a different file. If a SQL exception happens, I can say to the user, oh, we read your file, but we couldn't write it to the database, so please try again later. And if something else goes wrong, we can say, we don't know what's going on right now. We probably have a problem on our side. Check the logs and consult tech support. So those are 3 responses to maybe some service I'm calling that reads files and writes them to the database or something like that. And at a high level, all those things can happen. They could all be reusable behaviors, but I can handle them at the high level like this using multiple catch blocks instead of my try statement. So we certainly, starting Java, you don't need to deal with all this complicated stuff. I want to just plant some seeds for what this stuff means as you move forward and build Java programs. So you're not going to play with this at all right now, but as you go through and build programs, just understand the value of components, how I can define not only what the components do, but how components can fail. And Java allows us to handle them very intelligently because we can communicate to you. So it's kind of like, you go off and get a credit card. And the good side is you can buy stuff without having money in your pocket. The bad side is you can ruin your entire future because if you don't pay the bills, then we're going to add on tons of interest and come after you and put a judgment against you, and that money will haunt you forever until you get bankruptcy and ruin your credit score forever, and that's all the downside. Well, exceptions allow us to define that and give you a place to not only see the bad things that can happen. Hey, if I call this method, I could have problems with reading a file, but also gives you a way to handle it. Hey, if I call this method and has problems reading the file, then I can identify that compared to other bad things that happen and then tell the users accordingly. That's the important part for now. So use this for what it's worth and come back to this video as you get a little bit more robust in your Java knowledge and want to really start doing some advanced Java error handling.